I hope now we are good to move to the next slide. Here, as now we have learned about lines, let us understand about intersecting lines. Okay? Intersecting lines. When two or more lines cross each other in a plane, they are called intersecting lines. Make sure that you remember the spelling correctly of intersecting. Okay? The word intersecting means that they share a common point. The point that they are going to share, we call it the point of intersection. Again, a very important word. The point where the lines are intersecting each other, it is called as the point of intersection. Now let us see that how we can draw them. How we draw them? We draw them like this. First of all, we need two lines. Okay, so these are the two lines that you can see. Let me name this line as A, B, and this line as C, D. So what we see here is that line AB is intersecting line CD. Is that clear? How we can read this as? That line CD is intersecting line AB, or we can say that line AB is intersecting line CD. And you can clearly see that these two lines are intersecting at this point here, right? Let us name this point as point O. This is a very common point that you will see that always, in fact, most of the times, the point of intersection is named as point O. Okay? So, we see that these two lines are intersecting at point O. Also, another way to name lines. This is very important. Listen to this very carefully. Instead of A, B and CD, I can simply name a line as line L. And look at this how I have written L. When I am naming a line with a small letter, we try to write it in italics, like slightly they are tilted. And let me draw another line, the intersecting line, and let me name it as line M. So again, small letter, little tilted, that is in italics. So this is how now we know two ways to write a line. That is, we can write it as A, B, that is with the help of marking 2 points on the line, or simply we can mark it with such kind of small letters like L or M, okay, or N or P, any alphabet that you choose. But make sure that if you are putting just a single letter to represent a line, it should be in small letter italics, okay. Now, the question here says that can you see any pair of intersecting lines in this image? So look at the image in front of you. It is a rhombus. So here what we see in this figure, or instead of rhombus, I'm not sure whether all the sides are equal, so I'm not calling it a rhombus. Let me say this is a quadrilateral. Okay, we know that a quadrilateral has got 4 sides. So here this is a quadrilateral. How many pair of intersecting lines do we see in this image? In order to do this, let us first name this particular image. Let me name this as P, Q, R, S. So this is the name that I have given to this particular quadrilateral. Now let us see how many pair of intersecting lines are there. So do you see that this line PQ, it is intersecting line QR, this line here, right? So this is one point of intersection, that is point Q, right? Similarly, the line PQ is also intersecting line PS at point P. Similarly, the line PS, it is intersecting the line SR at point S, And lastly, the line QR is intersecting line SR at point R. So we can clearly see that in this image we have 4 points of intersections. So what did I just said? The points of intersection. Very important word to remember, that where the two lines are meeting, that particular common point is called the point of intersection. Okay?
Look at the animation. Take a rectangular sheet ABCD of tracing paper. Fold the sheet at B such that the side BA coincides with side BC of the rectangle. Press well the fold to make a crease. Now unfold the sheet and draw a line BE along the crease. Again fold the sheet at C such that CD coincides with CB. Make a crease along the fold. Unfold and draw a line CF along the crease. The two lines will intersect at a point. Mark this point as O. Observations. BE and CF are two lines intersecting in O. O is called the point of intersection of the lines BE and CF. Two lines can intersect in one and only one point.
Let us learn about parallel lines. The word is parallel. Parallel lines. In geometry, parallel lines are lines on a plane which do not meet, that is, two straight lines in a plane that do not intersect at any point are said to be parallel. So you can see the images here. I have actually kept an image for you so that you can have a clear idea with this, that how parallel lines should look like. So clearly you can see that the two lines here drawn in each of these images, they are going endlessly in both the directions, but they will never meet at any point. We just learned about intersecting lines, and the intersecting lines were meeting at a point of intersection. But here, parallel lines never meet each other. They are always at a certain distance from each other, and this particular distance between them is always fixed. Okay, so I'm just drawing a rough figure. This is not how a parallel line should look like though. So say these two are parallel lines. Okay, so the distance between these two lines, this distance, this will always be same. Always. Okay, and because the distance is same, so these parallel lines will go on and on and on and will never meet each other. Okay, they will never be intersecting at any point. Thus, what name do we give them? We call them parallel lines. Okay, so how can we name them? So say these are just lines. So we just learned that we can write a line as line L and this as line M, for example. So how I'm going to write it? I'm going to write it as L. Then I draw two straight lines like this and M. Okay, so this is how we name them. I'm just writing it again. Consider the last figure. Say this is P, line P, and this is line Q. So P parallel to Q. Okay, so this is how we name them. Now I'll just write another here. Can you tell me what have I written? We read this as line L is parallel to line P. This is how we write the parallel lines. I hope this is clear. Now let us move ahead in the lesson. Let's see what's next. Okay, so now it's time to think. Any 5 examples where you see parallel lines. Just look around yourself or think wherever you see parallel lines. I hope you can see anything which is around you which is parallel. Look at the wall. Do you see any parallel lines in the wall in front of you? Now look at the door. Do you see any parallel lines in door or in windows or on the table that you are sitting or on the chair that you are sitting? The cupboard in front of you, the road that you walk on. Do you see? These are all the examples of parallel lines. Let me show you with the help of some images. Look at these images here. The first image is the image of a racetrack. Do you see parallel lines here? The runners, the people who are participating, they are asked to, if it is a small race, say 100-meter race, so they run straight, in straight lines. And in order to make sure that they are running in the straight lines, the people, they draw these kind of white lines, the parallel lines on the ground. Now the second image you can see in front of you is the image of a flag, right? Do you see that in the image of flag, we have got parallel lines? The next image that you can see in front of you is the image of a rail track. Now, look at the fourth one. It is the image of a road, and I'm sure you must have seen these kind of yellow lines on the road in order to divide the traffic on left and right. So these are the lines, another example of parallel lines. And the last one, windows. See clearly we have so many parallel lines here. These two are parallel lines. These are parallel lines. These two are parallel lines. Okay, sorry for my bad drawing. So all these are the examples of parallel lines, right? Now let's see what is next to learn. Okay, so now comes ray. What is a ray? Let us define ray mathematically. A ray is a portion of a line. Very important point to remember. It is a portion of a line. It starts at one point. We call it the starting point, and it goes endlessly in the other direction. So this is how we define a ray. Let me just draw a line here. See, this is a line. This line, if I'm just writing it with the help of point O, A. Now, let me just do one thing. I'll just cut this part here. I'm just cutting this part. From this line, I'm cutting this part. So what am I left with? I'm left with this kind of image where I can see point O. I can see a line which is going endlessly in one direction, which is marked with point A here. So what I can see in front of me is a ray. A ray starts from one point. Here it is starting from point O. It goes endlessly in the other direction. So it is going in the direction of point A. This is a ray. Okay. So how we can draw? We just saw here that we can draw a ray with a point and it goes endlessly in one direction. This is a ray. How we can name them? We write ray as OA, and on top of it we draw a bar and put an arrow in just one direction. Okay, in line what we used to do, we draw these arrows in both the directions, but in ray we draw this particular bar and we draw arrow in just one direction. Okay, now how do we read them? So let me just write down here for you, say OB or PQ. So here we read it as ray OB, ray PQ. This is how we read such kind of symbols if you ever see it in front of you. Now, can we draw a complete picture of a ray? Think about this. Do you think that you can draw a complete picture of a ray? We discussed earlier in the same class that we can draw a complete picture of a line segment. Then we learned that we cannot draw a complete picture of a line. Why? Because line goes endlessly in both the directions, the opposite directions. Now comes ray. What do you think? Can we draw it? I hope you know that the answer is no. We cannot draw a ray. We cannot draw a complete picture of a ray. Why? Because even though it is starting at one point, but it is going endlessly in the other direction. So we can never draw the complete picture of a ray. Now let's discuss some questions so that we have a clear, even more clear idea of what a ray is. So the question reads, if PQ is a ray, so let us draw a ray. So it says PQ. So starting with point P, going endlessly in the other direction. So this is point P and this is point Q. Okay. So here it says, what is its starting point? Clearly we can see that it says PQ. Always the word, the alphabet that you see at first, it is the starting point. So here the answer is point P. Okay. What is the starting point? Point P is the starting point. The next part says, where does the point Q lie on the ray? So see, where does the point Q lie on the ray? The point Q lies on the direction which is going endlessly, right? So where does the point Q lie on the ray? It is lying on the endless direction. Okay. Now the next one. Can we say that Q is the starting point of this ray? What do you think? We just learned that we have just learned that P is the starting point, right? So do you think if P is a starting point, can Q also be a starting point? The answer is no. The Q here is not the starting point. P is the starting point. Okay. So now moving ahead in the lesson, let us see what's next. Okay. Again a question for us. The question says that draw a ray OA. We are going to draw a ray OA. You must be thinking that why they haven't written OA with the arrow on the top. So the answer is that because they have written the whole word here. They have written the whole word ray. So they haven't written as OA with the arrow over here. They haven't done this. Okay. Either you write the complete word or you simply put an arrow mark at the top. Okay. I hope this is clear. Now, they are asking you to draw a ray OA which is starting at O and passes through the point A. It also passes through point P. Okay, let us try how we can draw this. Starting at point O, it passes through point A. So let's say this is point A. It also passes through point P. So I can draw a point P anywhere. Okay. So here O is the starting point. A is the point that it is passing through and also it is passing through point B. So this is how we can draw the diagram. Make sure that when you are drawing all these diagrams, you have got a ruler with you. Okay. Always make straight lines. I'm just making these lines with a rough hand. You shouldn't do that. Make sure that you use the ruler and pencil to draw all the lines, line segments, lines, everything should be drawn with the help of rulers so that the lines are straight. Okay, so now looking at the first question, part A, it says, can you also name it as ray OB? So do you think we can name this as ray OB? What do you think? Yes, we can name it as ray OB. Yes, the answer is yes. Why? Because as we can see that A, B, or I can put infinite many points here on the line. I can put any number of points and I can just give them any number of names. Just the important thing here is that it should start at point O. Okay, so starting at point O, it can be point it can be a ray OA, it can be a ray OB, or if I have a point C here, it can be ray OC. So yes, we can give it any name, but make sure all these points are on the line. Okay, it shouldn't be like if here is a point T, so I can just name it as point T. No, I cannot do this. I can only name a ray with the help of those points which are lying on the line itself, the ray itself. Okay. Now let's move to the next one. Can we write ray OA as ray AO? What do you think about this? I hope you are saying in your head that no, I cannot do this. So if you are saying a big no, the answer is absolutely correct. You cannot name the ray OA as ray AO. Why we cannot do this? Because O is the starting point and A is what going in the endless direction. So if I'm reversing it, what am I doing? I'm starting from point A and I'm going to point O. But this is not a ray. This is a line segment. Okay, so we cannot name it as AO because A is a point, O is a point, and if I say AO, if I'm reading as AO, I'm basically putting these 2 points, and in between the line that I have, this is not a ray, this is a line segment. Okay, now the third one, what does the arrow on each of these rays show? So what are these rays showing us? They are showing that the ray is going endlessly in the direction, in just one direction, not both the direction. Here it's the end point. You cannot move further backwards. So a ray shows you that you can move in just one direction. So what is these arrows showing you? These arrows are showing you that the ray is going endlessly in a certain direction. Okay, with this, let me just ask you an example of ray. Do you think you have any example in your head where you can see a ray in front of you? Just imagine a bulb. So here, this is a wonderful image of a bulb. So when you see this bulb, it is brightening up. Okay, so the rays that come out, they are starting from this particular point. They are starting from this bulb here. And from this bulb, they are going outwards. The rays, they go outward. So this is one example of ray. Another example can be your favorite sun, right? And I hope you are also drawing the sun like I'm doing here. Do you draw it like this? From my childhood, I used to draw the sun like this. So do you see that in the sun, it is starting here at a single point. This sun, it is starting from this point here. And the rays, they are going endlessly outwards in all the directions. Okay. So thank you, sun, for this beautiful example. This is an example of rays, right? Moving ahead. Let's quickly revise what all we have learned in today's lesson. So we have learned about point. This is how we draw it, a point. We name it as point A. Then we learned about a line segment, which is always bounded by 2 endpoints. So this is line segment AB. Then we learned about line, which goes endlessly in both the directions. Then we learned about intersecting lines. And then what we learned about was parallel lines. They should always be going on and on and on, and they should never meet each other. And then we just learned about ray, which starts at a particular point and goes endlessly in the other direction. Right?